So, in your notebook, I want you to write the following as prime numbers to a power. Prime numbers with an index. So a bunch of numbers are going to appear on this left side. For instance, 2 to the power of 2 times 2 to the power of 3. I want you to write that as a prime number with an index or a power. There will be many of these. You will need to remember some of your rules for indices, right? Doing these. Um, do your best. I will talk about them all in a moment, but here's your hint. If the base is not a prime, can we rewrite it as a prime number to a power? Uh, so do your best on these. Write them as prime numbers to the power of, right? And then I will talk about the answers. So I'll give you a second, pause the video, write down all your answers, and then we will talk. Okay, so let's talk about these. Um, so our very first one, 2 to the power of 2 times 2 to the power of 3 is, oh yeah, here's your nice anime gifts. We get 2 to the power of 5, right? Because our rule is we add the indices together. 2 plus 3 is 5. 2 is already a prime number, so we get 2 to the power of 5, right? The next one, these are both negative numbers, so when we add them together, they stay negative. It would be 3 to the power of negative 4. This one, we have two fractions, right? You add fractions. We need to make sure you know how to do that, right? 1/2 is also equal to 2/4. 2/4 plus 1/4 is 3/4, so we get 5 to the 3/4 power. This is not in power or indice form. This is in the root form. So the fourth root of 5 times the square root of 5 is the same as this, right? 5 to the 1 over 4 is the fourth root of 5. 5 to the 1/2 is the square root of 5. So the answer is going to be the same. When you see these, I would suggest transitioning them into the indice form and then doing your calculation. That makes them a little easier. When you see something like this, you are multiplying these two numbers together. Instead of adding indices, you're going to multiply. So 2 times 3 gives you 3 to the 6th power, right? All right, here is where we get bases that are not prime. So you're going to have to remember some prime factorization here. So we have 4 to the power of 2, which would be 2 to the power of 4, which if we think about it, 4 times 4 is 16, right? 2 times 2 times 2 times 2 is also 16. A trick you can do is you can take this 2, right, which is prime, and 2 times 2 is equal to 4, right? And then you can imagine it's something like this. So 2 to the second power to the power of 2 now would equal 2 times 2 is 4. So 2 to the power of 4. You can continue that process for 8 to the power of 3, right? We can go again with 2. So 2 to the third power is 8. And then 2 to the third power to the power of 3. 3 times 3 is 9. So 2 to the ninth power. And this last one is 3 to the 8th power. That's because 3 to the 4th power is 81. And then 3 to the 4th power to the 2nd power. 2 times 4 is 8. 3 to the 8th power is the answer, right? So our last topic today is surds. And this has to do with what we've been talking about, right? So we've been talking about roots and those fractional indices. But a surd is when the stated root of a number isn't an integer. So here's an example. The square root of 8 is a surd because it cannot simplify to an integer. Put this into your calculator, you will not get 1, 2, 3, 4, right? The square root of 25 is not a surd because it can simplify to an integer, which is 5. So there's actually a fairly easy way to estimate these, which is my hint. Before I tell you the trick, I want you to try and figure these out. So which of the following numbers are surds, which are not surds? So pause the video, take a shot at it, and then I will tell you the answer. So the answer here, let's just take a look. The square root of 4. This one you might be able to tell just by looking at it, right? We know 2 times 2 is 4, so 4 would not be a surd, right? 4 is not a surd because 4 to the 1/2 is 2. 2 times 2 is 4. I think I mentioned this one earlier. The cubed root of 27 is not a surd because 3 times 3 times 3 is 27, right? But these two are surds, and we can estimate them, right, by thinking of squares, in this case, for 30, the square root. Thinking of squares that are close to 30. So 5 squared is 25, right? 5 times 5 is 25. That's close to 30. And 6 squared is 36, right? So because we have these two integers that are right next to each other, and their squares are not equal to 30, we know that 30 is a surd, right? Because this is 25, lower than 30. This is 36, higher than 30. So 30 has to be a surd. There's no integer in between these that could equal 30. Same thing with 64. This one's a little bit tougher. You probably don't know the fifth power, but if we're looking at the fifth root of 64, we can just start estimating. So the fifth root of 2, or sorry, 2 to the fifth power is 32, right? That's not too hard of a calculation. And then 3 to the fifth power is 243, right? So this is less than 64. This is greater than 64. There are no integers in between 2 and 3. So this has to be a surd. So that's how you can easily estimate surds when you're looking at this. All right, so that is all I have for you today. I know that was a lot. To show your understanding, do the exercises. Oh, that's typo. Oops. Do the exercises that are on worksheet 2. And then I'd also like you to answer a couple of discussion questions that I'm going to put on ManageBack. Those just help me know where you're at because I'm obviously not there to hear your questions and talk to y'all about that. So please do the worksheet and answer those couple questions I'm going to put as a discussion on ManageBack. All right, see you next week.